Let's learn about lecture 32 of matrices. So there is one note written over here. The note says that B transpose AB, this particular product B transpose AB will be symmetric if A is symmetric, and this same product will be skew symmetric if A is skew symmetric. Okay, so let us learn this particular properties proof. B transpose AB complete transpose will be equal to B transpose A transpose B transpose transpose. How? This B will come in the front and transpose will come here. This A will remain in the middle and transpose will come here, and this B transpose will go in the end and it will become B transpose transpose. Which property have we used? We have used this particular property, that ABC complete transpose is equal to C transpose B transpose, okay, A transpose. So this particular property we have used over here in this particular expression, that B transpose AB complete transpose is equal to B transpose this B comes over here, B transpose A in the middle remains in the middle, transpose B transpose, which is the first term, will go in the last, and B transpose will happen. Okay, now B transpose is equal to B transpose, A transpose is equal to A transpose, and B transpose transpose. When we take transpose of transpose, we get the same matrix. So we got B over here. Now have a look. Consider this A transpose. We know this very well, that A transpose will be equal to A when it is symmetric. So when A is symmetric, what will happen? This A transpose will convert into A. So B transpose AB, if A transpose is equal to A, that is A is symmetric. And if A is skew symmetric, instead of symmetric, then if A is skew symmetric, then A transpose will be equal to minus A. This is the case for skew symmetric. This is the case for skew symmetric. Okay, so A transpose will be equal to minus A. So this will open up like this, minus B transpose AB. So you can have a look. I have written it once again over here. B transpose AB complete transpose is equal to B transpose AB if A transpose is equal to A, that is A is symmetric, and it will be equal to minus B transpose AB if A transpose is equal to minus A, that is A is skew symmetric. Okay, hence this particular fact that B transpose AB is symmetric if A is symmetric is proved, and B transpose AB is skew symmetric if A is skew symmetric, that is also proved. Okay, so based on this particular proof. Thank you very much.